3 webinars. You can find the other 2 webinars on YouTube, and you can just review them if you'd like to. Each webinar actually talks about like specific aspect of production, reservoir, and drilling in oil and gas industry using Python or utilizing Python. So it will be very beneficial if you go ahead and review those webinars as well. So what we will be doing in today's webinar is actually, I will take you through the process of writing Python codes to do some actual workflows in oil and gas industry. The workflows actually I do present, they are the actual use cases of Python, not just some nonsenses from like copying like some equations that does not actually make any sense in oil and gas industry. So without further ado, let's go ahead and start. So the first thing I would like to say is actually you don't need to know anything about Python to understand or even to have some clue of what's happening in this webinar, because I will take you through the process of writing code in Python from scratch, from zero. So if you do not know anything, by the end of this webinar, you will actually will learn a lot of things. And if you do know some basics of Python, you will gain more knowledge. So let's go ahead and start. So today's webinar is actually, we will create some visualization dashboards using Python. But before we do that, let me just go ahead and show you some data in Excel sheets. Excel sheet, actually, they are our friends in corporate or company environments. However, Excel sheets, they have some drawbacks. For example, actually, Excel sheets, they are very rigid. Sometimes they are not flexible. And the plotting does not actually allow you lots of customization. Plus, if you want to do some heavy calculations on Excel sheet, and you are bounded by the interface that Microsoft created, meaning that the heavier the calculations, the more the sluggish the interface you will have. Unlike Python or other programming languages where you can utilize in order to create beautiful visualizations with some heavy calculations on the background. So this is the beauty of using Python. So this is one of the data sets that we will be working today with. This is from Wolf dataset. By the way, all the data plus the code, you will receive it. And once we publish the video on YouTube, you will find those data on the description. Now, let me introduce you to the columns. So the first column is the ID, is just some generic ID, which increments by one, for example, 43, 44, and this is just a by one increment. And you have the production day, you have the well name, the oil rate, gas rate, and the water rate. So for example, if you want to plot, for example, 2 variables in Excel, what we will do, actually, we will go ahead and do something like this, just highlighting these 2 columns. And then maybe we go to insert, maybe we use some recommended charts, and maybe we use some scatter plots or something like this. And there we go. This is the basics. The plot you can get. By the way, you can customize this plot in Excel. However, the customization comes nowhere close to the customization that you can make in Python. Now let's go ahead to some of the drawbacks in Excel that actually that restricts you or actually puts some severe limitations on how you can create dashboards in Excel. For example, we have something close to 15,000 rows. As you can see, not all of these rows actually correspond to a single well. For example, you have multiple wells that their data actually they are sitting on this Excel sheet. So how can we actually extract like a single bit of well? So basically what we will do is we will highlight all of the columns, and then we go to data, and then we will activate the filter. Once you activate the filter, now you can get all of these wells And then once you select like one of the wells, now you can just retrieve the data for that specific well, and you go ahead and recalculate or just replot everything. As you can see, once I did this filtration thing, actually the plot just that it was missing somewhere, so I don't know where it went. So basically is if you want to do some heavy filtering, some heavy interaction with Excel, is basically Excel is very sluggish. Plus, if you're working with digital oil fields where thousand upon thousand of data are being added each single hour to your database or to your data warehouse, actually Excel is your last option to consider. Luckily, Python comes to rescue. Using Python, we can create lots and lots of visualizations, dashboards, and lots of things. So without further ado, let's go ahead and introduce you to the tool that we will be using. So the tool is called Streamlit. So if you search for Streamlit, you will encounter this website, streamlit.io. Please, if my voice is not audible, please go ahead and write in the chat box. Otherwise, just type #1 or something similar. So basically what a Streamlit is actually a web-based library that allows you to create beautiful dashboards with components like buttons, text box, and charts, tables, and etc. etc. This is all using Python only. By the way, Python is a programming language. It's free, it's open source, and there is a huge community for Python. Plus, Python started to get to generate some traction in different industries. For example, artificial intelligence, oil and gas, aerospace, and chemical engineering and food manufacturing. All of these companies actually they do utilize Python for a specific or like for like a set of benefits that they derive from Python. So one of the things that you can utilize Python to do is actually to create dashboards. So let's go ahead and see in the gallery what types of the dashboards you can see. For example, if you just click on these dashboards, you will see like different samples or examples of what actually you can create. For example, let's select like this plotting dashboard. Once you click on it, actually, it takes some time to load because it's already hosted on the cloud. That's why it will take some time. Plus, the internet connectivity is a huge plus if you have a good connection. So this is basically what you can create using Python. Plus, the way or the data that is created or the data that's utilized in these dashboards that we will be providing those data. So this will be customized to oil and gas data. So basically this is our dashboard. And we can go ahead and just view it in the white mode. By the way, this is just a free thing that you can view as well. So if you go to Streamlit application gallery, you can actually find these free samples. You can interact with these. You can change them. For example, you can change, you can scroll, you can just disable some of the curves. And basically what interactions you will do is we will be creating something similar to this in Python. However, it's going to be on our local machine. So let's go ahead and start. First of all, what we will need to do is actually we need to add our data to a specific folder. For example, my folder that I am adding my data in, it's called data. You can see I have 3 data files. The first data file is actually, it contains the deviations of the set of wells. Plus, we have an Excel sheet, which is called production, where it contains production data. And we have some CSV, which contains like all the static or basic information about the wells, which is the x-axis, y-axis, and the date of spud and things like this. So basically, we have 3 pieces of data. We will create a dashboard that combines all of these data together. What you need, actually, you need to use any Python editor or any Python IDE for this instance, I am using Visual Studio Code. However, you can go ahead and use whatever you like. And if you are using Visual Studio Code, what we will do is we will go to the option Open Folder, because we already structured our data in a folder. So the folder is called Data. I will click on Select Folder. Once you do that, now your workspace is ready. As you can see on the left-hand side, you have those data presented or those file presented. By the way, Visual Studio Code is an open source and free tool to use. So you can go ahead and grab it from Microsoft website. And as you can see, each data type or each file type contains like a specific icon dedicated to it. And now the next step actually is we need to create our dashboard. How we can do this? First of all, we need to create a new file by right-clicking on this empty space and then selecting new file. And then we will name our file. Let's call our file dash, like a acronym for dashboard. So a short for dashboard, sorry. And then we will write .py. Usually Python files will end with .py. Py is standing for Python. And you click enter. Once you click enter, there we go. Now you have an empty Python file. In this file, actually, we will start writing our code. So what we will need actually is we need to import a couple of libraries that will actually facilitate plotting and dashboard creation for us. So the first and foremost library we need to import is called Streamlit. Importing Streamlit actually provides those functionalities for us. For example, displaying plots, buttons, text boxes, and tables and similar things. So what we will do, we will type import. By the way, typing import in Python, meaning that you want to export some library that's usually not shipped with Python. These type of libraries actually, they are installed. Sometimes you have some libraries that come with Python, but however, you have to use import to get it manually. But just keep in mind, using import actually adds functionalities to Python that it does not exist by default. So we will import something called Streamlit. Streamlit is basically the library that this website or this company created. So there we go. Sometimes library names are just too long in Python. We do not like to deal with them like in this long format. What we will use actually is we will follow the name of the library with the keyword as meaning that you want to give a different name to this library. It's known as aliasing the library. So we will call it as st, meaning that whenever I try to call this library next time, I will use the word or the keyword st. I will not type the name Streamlit again. So this is basically, I'm just giving a short name to the Streamlit. This is known as aliasing. So let me just type comment, aliasing the library name. By the way, the code and the data files you will get, and you will find it in the description in the YouTube channel. Once you do this, this will allow us to create like various things. So the first thing we will create, actually, we will create a header for our library, for our application. So how we can create header, we will type st dot. Whenever you type a dot after the name of the library, this means actually you want to like access functionalities in that library itself. One of the most used functionalities is called header. Header actually provides just a big text, like it's a welcoming text to your application. You open and close the parentheses, and then you provide a string. This string actually will contain your welcoming message to a user. For example, let's call this a sample oil and gas field dash port. There we go. Now let's add another thing, like let's add some description to our page. For example, st. If you want to add some description to your application, you will use another keyword called caption. By the way, caption is just like a very small, and it's not a bold text. It's very small in size, and it's not easily noticeable. So it's used actually to describe or provide description for specific applications. For example, we will use this to welcome to our company's dashboard. Use it on your own risk. This is basically like two messages. The first message, which is the header, this is just a bigger font. The caption, this is a message as well. However, this is the font is smaller and it's lighter in color. Now we have two components in our application. Now it's time to actually run the application. So how can we run it? First of all, what you need is you need to go to terminal. You click on this, which is new terminal. This will actually open a new Python terminal for you. Just wait for it to load. It will take a couple of seconds. Once everything is loaded, now it's time to run our application. But before we run our application, it's very important to save. You go ahead and save it by pressing on Control S. So once you do that, what we'll do is in the terminal, we will type Streamlit, which is the name of the package or the name of the library we're using, and then run, meaning that we want to run the Python file that contains Streamlit command. So the name of the file, which is dash.py. There we go. The line of the command actually contains three keywords. The first keyword is the name of the library, and the second thing is the type of the action that we want to provide, which is usually going to be a run. And the last thing, or the last keyword, or the last name, it's going to be the name of the Python file that we have created. If you have paying attention from the beginning of this webinar, we created a file called dash. By the way, the shorter the name, the better, because the longer the name, the more the chances you will have to mistype the name of the file. So the shorter name, the better. So once you do that, go ahead and press enter on your keyboard. It will do its thing. Just wait a couple of seconds. And once your application is ready, it will load up a website. This is, by the way, this is loaded automatically, so you don't have to do anything. So as you can see, I have created a website, or this is known, by the way, this is known a web application. This is not a website. This is known as a web application if we want to be technical about this. And it contains two things. The first thing is actually the header, which is in like a very big font, and the description, which is like in lighter and smaller font. So basically, this is our application. Now our application is ready to be like adding more stuff to it. So if everything is good so far, please go ahead and type in the message box. If not, so we can go ahead and review some of the things that we did so far. But hopefully everything is clear so far. Now, the only thing that we did is actually we imported the interface, which is the Streamlit. And now the next thing we need to create is actually we need to start to import our data. And Python is one of the best languages that allows you to work with tabulated data, like Excel sheet, CSVs, text files, and things like this. So in order to start working with tabulated data, we will not open and read the file manually. It's best to be using a third-party library called Pandas. So we will be importing something called Pandas. Pandas is just a library that allows you to read Excel sheet and CSV in just a single line of code. So you don't have to pay attention to the details inside those files, which is very cool. So I will give it an alias as PD, which is short for Pandas. Once you do that, now it's time actually to import some data. So the first thing I will import, actually, I will import the production data, which is contained in this Excel sheet. So the file name is prod.xlsx. So how can we do that? I will need to create a variable. I will call the variable prod data, which denotes production data, equals to, this is a variable. So whatever is read on the right-hand side, it will be saved on the production data, on the prod data variable. So I will type the library name, which is the PD, because Pandas provides you the functionality to read tabulated data, and then dot meaning that I want to access sub functionalities, and then read Excel. Read Excel is actually a function inside this library. It provides you with the functionality to read Excel files. You open and close parentheses and provide a string. This string you provide is the name of the file, which is prod.xlsx. So hopefully this is very clear. By the way, once you do that, you only need to save it. And once you save it, everything will be reflected on your application. Now, do you see new message that popped up in our application saying that source file has changed? So it's asking me what action I need to do. So should I rerun this or always rerun? So you should actually choose always rerun, meaning that whenever you save your file, it will just automatically update everything for you. So let me just put this next to my application. There we go. So you have everything side by side. Now it's time actually to start viewing the data. So how can we view the data? Viewing the data can be done using a couple of methods. So I will give you the first method, which is the simplest and the most primitive of all, which is using something called st.write. Write is something very similar to print. However, this is used for the Streamlit or the web application. So you inside this write, you can provide anything. You can provide text, you can provide numbers, you can provide tables, you can provide anything you want. So in our case, we'll provide the name of the variable that contains the tabulated data that it was read off from the Excel. So save everything and watch your application running and refreshing itself. Once it do that, you will go ahead and see all of your data. Now it's being plotted inside the application that we have created. So this is the first method. So let me just write first method primitive. So this method is very primitive. So there we have some more advanced and better ways to do this. So second method, which is recommended. What we will do is actually we'll use something called st.dataframe. Data frame is actually meaning that you want to print table. By the way, sometimes programming languages has those fancy names for like basic things. For example, tables in Python, they are not called tables. They are called data frames. So you should know these namings. So in this instance, this is a table. However, it's called data frame. So let's pass our table name, which is production data. By the way, if you want to stop some specific code from running, you can convert that code into a comment by including a hash pound in front of the code. So the code will go green. Every green code in Python, it will not be run. So this is invisible to the compiler or to the interpreter. So save everything. Wait for your application to load again because we have did some changes. There we go. And now this is the data frame that we have created. They might, by the way, they might look similar. However, they have like some distinct changes. For example, in data frame, you can do some sorting and things like this. You can edit your data and some more functionalities as well. Now, once we have done viewing our data, now you know your data exists. So it's time to do some plotting. This is, by the way, this is one of the most challenging things to the newcomers to the Python. However, I will teach you a very simple way to do this. Usually, viewing the data in this format is very useless because you are just viewing everything. This will make your application sluggish. Plus, and it will make your accessibility to a specific piece of data very irrelevant, because you are viewing 15,000 lines of code. So it's not practical, to be honest. So let's just comment out everything and try to extract some useful informations about this table. So for example, usually whenever you're trying to create dashboards for oil and gas, the first thing actually you need to think of is some form of identity that your field or that your station or your processing facility has. This identity is usually, for example, names of wells, names of facilities, names of equipment, like names of reservoir. If you have a single reservoir, it might contain multiple units. So the name of the unit, like name of pattern. So those are all under identifications. In our data, the only identification we have is the well name. So we have to extract the well name from this table. By the way, using Pandas is very, very easy to do this. So let's extract our well name. So I will create a variable called well names because we will get multiple names. So well names equals to production data. So production data, you open and close square brackets. Square brackets actually means that you want to access like a specific column, and you will provide the name of the column, which is well named. By the way, you should pay close attention to the casings or the capital small letters, because the casing is very important in Python. If you change this like to small a, this will throw an error, so you have to pay attention. Once you retrieve all the data from this column, you will follow it up with something called you will do this. And once you import, or once you get the well names, let's go ahead and print them. So we will be printing them in this application using st.write and then well names. By the way, once I save, this table will be disappearing because I have stopped every command from running. So let's save this. However, you should get a list of the wells names. So this is what you will get. This is a list of our well names. But if you pay a close attention, the well names is just a lot. We are getting 15,000 well names because some of the well names, most of the well names, they are just repetitive. So you need to filter out those repetitive and only get the unique ones. So how can we do this? In line 14, which is production data, you will follow up your line with .unique. Unique, actually, it will only return the wells that are actually, they are unique and non-repeating. So save everything and watch your results again. There we go. Now we are getting only 7 wells because all of the repetition and all of the repeating items are now gone. We have only 7 wells. Do you remember in the previous step, we had like 15,000 wells, which was not correct. Now this is the correct well numbers. So once we do that, now we have our list of wells. Now it's time actually to create some plots based on these well names. So what we will be doing actually is we will be giving the user the option to select which column or which variable to plot against time. So let's go ahead and do that. But before we do this, actually, we need to actually retrieve the available column names. So let's create another variable. We call it columns, or let's call it variables. By the way, you should use plural if you're actually your variable. If you should use plural if your variable contains multiple values. This way you will know like what types or what sort of values you have in that specific variable. We will type the name of the table that contains our data, and then we will follow it by .column like this. This will actually provide all the columns for us. So let's go ahead and check our result by printing them. st.write like this, and then variables. So let's go ahead and print our variables, save everything. and watch for the results, we should get a list of the available columns that we can use for plotting. Now, if you notice that so far, actually, we are presenting the results as a text. We cannot actually utilize them like in a select box or something. This is just a table. It's true that we can select the table. However, nothing will reflect in our application. What we want actually, we want the user to be able to choose which variable he wants to select. So let's go ahead and do that. So I will create a variable. I will call it x-axis select equals to, I will introduce you to a new component or a new functionality in Streamlit. It's called st.select box. Select box actually provide you a select box that you can use it to select a single thing among like multiple of options. So the first thing you provide actually is you provide a message, which is select x-axis, or you can just provide anything you want. And then you provide the options, which is going to be the variables. So the first thing is the message the user will see. The second thing is the options or the variables that you want to the user to select from. So save everything. And wait for your application to load. And there we go. Now you can see we have something new, which is called select the x-axis. Once you click on it, now you have the couple of options you can select from. For example, you can select the date PRD, you can select the well name, you can select the Q oil, you can select multiple things. So let's go ahead and add another variable for the y-axis. I will copy this, paste it below, just change the names. So I will make it like y and then select y-axis. There we go. Save everything. Once you do that, now you should have the option to plot actually two things or select two things. So the x-axis and the y-axis. So this is the x-axis and this is the selector for the y-axis. The only thing remain actually is it remains the plotting that we need to do. This is very easy, by the way. We need to import a new library. It's called Plotly. The Plotly library actually will provide us the functionality to create some plots. So we will use import plotly.express. This is, by the way, a newer version or newer addition to Plotly. This is a fast way of plotting. So as px, this is just an aliasing. So the library name is plotly.express, but I will name it to px. Now it's time to create some plots. So how can we create a plot? First of all, you need to create a variable. Let's call it figure. By the way, you can call it whatever you like, or let's call it my plot. And then you will type px, which it's short for plotly. And then you will type line, meaning that we want to create line plot. By the way, you can use scatter as well. You can create multiple things with this. So it will requires you three variables. The first variable is actually the data table that you want to plot, which is production data. The second thing actually it requires you is actually the name of the x-axis that you want to plot, and then the name of the y-axis. So if you were not working with dashboards, usually you will type the name of the axis like this, like date PRD, maybe Q oil, something like this. So this is known as hard coding. So now that you have given the user the option to select which variable he wants to plot, now it's time actually to type the name of the variable that the user is using to select his variables. So which is going to be the x-axis select and the y-axis select. So once we do that, now it's time to present or to view our plot. So you can see in line number 21, the plot is already created. However, you will not see it. If you want to see the plot, you have to display it. So how can we display it? we will display it since we are displaying it in the Streamlit application. So you will use st.plotly chart. So Plotly chart actually will plot charts from the Plotly library only. So you open and close parentheses, and then you will provide the name of the plot, which is my plot. Save everything. Once you save everything, now you will have the capability to do some plotting. So let me just maximize everything. And there we go. Now we have started seeing some plots. Now let's change some options. The x-axis, I will set it to date production, and the y-axis, I will set it to like Q gas. Wait for the application to load. By the way, usually working with Excel is somewhat sluggish. However, like there are like lots of ways we can enhance the performance of this application up to like 10 times faster. However, it's out of the scope of this webinar. So now we can see like all of these data we're having. But however, if you pay a close attention, or if you know your data, you can see all the wells are plotted on the same color. So meaning that you cannot distinguish the wells because they are all plotted as dots, and all the dots are blue. So what can we do about this? It's very simple. That's why we have used Plotly. Plotly provides you very simple solutions to like complex issues. So after Y, I will provide another function which is called color. Color actually is just categorizes your points based on like a specific criteria. So my coloring criteria is going to be the well name. So based on the well name, I want the Plotly to decide which points to color. So we can categorize our wells, save everything, and wait for the results. There we go. Now we have our points having different colors. By the way, if you go to these three lines, which is known as hamburger button, if you click on settings, you can activate the wide mode. Your application is going to be wider. And basically, this is the plot that we have created. By the way, double clicking on specific well name, it will activate that well only. By the way, you can just go ahead and deactivate a bunch of wells. And maybe you can keep like 2 wells for comparison purposes, like this. And by the way, you can zoom in some of the plots, and you can just pan everything out. Plus, you can just download this as a PNG. Once you download it, you will find it in the downloads like this. There are like multiple ways to export like high quality pictures out of this, but it's out of the scope of this webinar. Now we have this thing ready. And the only drawback about this application, actually, it does not select or does not allow the user to select which well he wants to plot. So now let's go ahead and add a functionality, which is a third functionality, where we will allow the user to select which well he wants to plot. So let's go ahead and do that. We will just append it below the select y-axis. So we will do something like select well. As you guessed, it will be st.select box, and then we will provide our message, which is select a well. And then the options, we will get it from the wells names, which contains all the wells. So well names like this. Save everything using Control and S on your keyboard and wait for the results to reflect. Once you do that, now you have a third option, which is called select a well. You can select whichever well you want to plot, but let me warn you about one thing. If at this point, if you select a specific well, it will not do anything because the data is plotted, it's not filtered. So what we need to do is we need to take the input from the user. For example, if he selects the well F14, we will take the well name and then filter out the full data, and then we need to plot that data. So basically, this is how filtering works in Python. And it's very seamless and easy to do. So let's go ahead and do one thing. In order to plot, or sorry, in order to filter the production data, let's call it filtered data equals to prod data, which is the data we want to filter. And then we will use the column name that we want to filter, which is production data, which is well name. So the well name should be equal to the select well, which is the user selected well. Once we get the filter data, now it's time to replace the filter data or replace the production data in line number 24, which is plotting everything with only the filtered portion of the data. So we call filtered data. Go ahead and save everything. Wait for the results. And there we go. Now you can see you already have like smaller amounts of data. You can change the well. And once you change the well, you can see actually the results and reflecting and the shapes of the data changing. There we go. Now we have different results based on the different selected wells. But what happens if you want to compare like two wells together? Now, this is the challenging part. Luckily in Python, this is very easy to do. And we will do it in a way that's very flexible and it's very easy to do. So what we will need is actually, we will need to convert this select box, which is line number 20. We will convert it to .multi-select. This will allow the user to select multiple wells at the same time. So let me just show you. For example, we will select the well F12, and then we can select the well F4. You can see it's just compiling or just adding the selected wells. You can just use this for the comparison purposes, or you can, this is very beneficial if you want to like monitor specific wells, or maybe you want to compare it to like offset wells. So this is very useful. As you can see, Python actually started to throw some error because I have some issues in my code. So we need to adjust the code .in. So let's convert our code so that it can go ahead and reflect our changes that we made. So as you can see that as you can see, now I have selected 3 wells and all of the wells are just shown. So let's go ahead and remove one of the wells by clicking on this X button. Once you do that, it only remains 2 wells. So by the way, the well F4 actually is an injector well. That's why it does not have any values. So let's go ahead and select another well for the comparison purpose. So let's select 15 and F1 and try to get some plots. There we go. Now we have 2 wells selected. By the way, you can go ahead and do all of these interactions with it. Now, the next part is what happens if you want to start to pull data like from another file. If you are doing this in Excel, you will know this is very, very challenging to do if you want to link multiple Excel sheets together. But in Python, you can do like create like hundreds of files and link them together using like some uniform dashboard like this. So let's go ahead and try to import another file. So in the line below, I will start importing another file, which is called the deviation survey. So this is basically my deviation survey. Let's go ahead and import it. So I will create a variable called deviation equals to pd.read_CSV. By the way, this time I will use read CSV instead of read Excel because the type of the file is CSV. So we will provide the file name, which is going to be dev.txt. The file name has to be exact and the same letterings. And then what we will do is actually we need to provide the type of the separation that the file has. If you pay close attention to this file, actually this is separated by a tab. These are the columns are separated by a tab. So how can we tell Python this? We will just write / and then the letter T, and it will know that we are having it in tabs. So let's go ahead and do something. st.write, let's just view everything, save it. Now you should have your Python application pulling data from 2 different data sources. There we go. The first data source is actually the production data, and the second one is actually the inclination and the offsettings of the well. By the way, I can pull the user inputs from this data file and then insert it in the second data file. So as you can see, this table actually, this is a still row, meaning that this is unfiltered. By the way, you can go ahead and filter it based on the user selection from the previous data source. This is very simple to do, by the way. I know it sounds scary, but it's very simple to do. So let's go ahead and create a new variable called deviation survey filtered equals to deviation survey. So what is the criteria that we want to filter? Our criteria is actually the well name. So we will create dev well name. By the way, just check the well name column. It should be the same. So well name dot is in, meaning that you want to filter multiple values. This is what it means. So we will filter it based on the selected wells. Save everything and watch for the results. Whenever you select like specific wells, only those wells will have their data shown in the deviation survey. So you can see we have the well F15 and the well F1C. So you can see the well F1C and then the well F15. And by the way, we can do more things. For example, we can just go ahead and create some plots for the MD and the inclination. And as you can imagine, we can create multiple plots. And yeah, so basically this is it. We will conclude today's webinar. Hopefully you learned something new. If you're already having like good knowledge in Python, at least you should gain a couple of new skills. Otherwise, you have just refreshed your knowledge. So I'd like to thank you so much for sticking to the end of the webinar. So thank you so much. It's very comprehensive. You will have all of these files. The files contains multiple things like coding, using dashboards, Plotly, basic Python codings and things like this. Plus, we have some extra materials that we usually provide. One of the most important things that we do provide actually is that the code base for our training. The code base for our training is actually one of the most valuable assets that we have in this training. This is like this example book. It contains something close to 30 examples, fully scripted, and it contains all the Python snippets, plus all the equation that's used to create the solution. Plus all the Python code has like comments, so you know what's happening in the code. So basically you will get this as well once you decide to join the training. So you'll get this from the day one. So thank you so much for joining. Hopefully I see you in the training. If not, hopefully we can see you soon, like in another webinars.